Okay, so today we're going over the final exam review, part 2. So let's start off with the first problem, 22. It says here, given a triangle RSW is congruent to triangle VUT, list all the corresponding parts. So what I do here is I'm going to start off by figuring out what parts correspond to each other. So I know angle R corresponds to angle V. So that means these two correspond to each other. So we start off by listing the corresponding congruent angles. So I say angle R and angle V correspond to each other. Okay, the next one, it says S and U. So angle S right here and angle U correspond to each other, which leaves the last two angles, angle W and T, which correspond to each other. Okay, so that's those. And then we're going to list the corresponding sides. So first side, we say RS corresponds to VU. And we looked at that by looking at the name as well, RS and VU. Okay, next one, we have SW and then UT. So SW and then UT, that's another side, which leaves the last side, which is RW and then TV or VT. That's all our corresponding angles and corresponding sides. Okay, now let's get into question number 23. So here it says that the figure below is a parallelogram. So you're going to solve for the length of LM. So in the parallelogram, you know opposite sides are congruent. So this is congruent to this side right here. So to solve for side LM, you set the two equations equal to each other. So 6x minus 7 equals 2x plus 9. Then next thing I do is I add 7 to both sides. So I get 6x equals 2x plus 16. Now I'm going to subtract 2x from both sides. So I get 4x equals 16. Divide by 4, I get x equals 4. Okay, so once I know x equals 4, now I solve for length LM. LM is this equation right here. So I take LM equals 6x plus minus 7. My 4 right here, and I just take it in here. I'm going to plug it in right there. So I get 6 times 4 minus 7, or 24 minus 7, which gives me an answer of 17. So LM has a length of 17. Okay, in the next one, I want to solve for the value of y. So I know that y is on this side, mn. Opposite mn is LO. So these two are congruent. So I'm going to take these two equations and set them equal to each other. So I just take 12 equals y plus 3. I just subtract 3 from both sides. I get 9. So that means my value of y is 9. So y equals 9. Okay, question number 24. Okay, so I want to solve for the length of Ks, and I want to solve for the value of Ek. Okay, so if I look at, this is a kite. So I know on a kite, here's a 90-degree angle. And I know this side and this side right here are congruent to each other. So it's always the shortest side congruent to each other. This bisects it in the middle. So that means that this side right here is 2, which means that Ks over here is also 2. So this is also a value of 2. So I'm going to say Ks is equal to 2. All right, so now I want to solve for the value of Ek. So Ek, if you look on your triangle, Ek is this side right here. So then I want to solve for that side. Okay, so do this. You put 2 marks right here. This, or 3, I mean. Okay, so now I want to solve for EK. So EK, if you look at the triangle, it's part of this triangle right here. So what I do here, I use Pythagorean theorem, a squared plus b squared equals c squared. I'm going to take ES squared plus KS squared equals EK squared. And I know ES is 3, KS is 2. So I'm going to square those. So I get 9 plus 4, which gives me 13. And if you remember to undo a square, I just square root it. So that means EK is square root of 13. Okay, now question 25. They're asking here, find the area of the rectangle ABC and triangle PQR. So if I look at my rectangle, let's find my dimensions, my base and my height. So think of this as your base right here. So this space here is length of 1, 2, 3, 4, 5. So I have a length of 5 right here, a base of 5. And if I look at my height right here, is 3. So what I do first, I know area. So for this one, area equals base times height, or 5 times 3, which is 15. Okay, now for my triangle, again, I look at my base right here, which is value of 1, 2, 3, 4. My height here is 1, 2, 3, 4, 5, 6. So again, here the area for this one is 1/2 base times height, or 1/2 4 times 6. And again, 4 times 6 is 24. So half of 24 gives me 12. So this is my area equals 12. Okay, now number 26. So here I want to solve for the value of x. So what I do here is I take my 2 interior angles, I add them together, and then I set it equal to my exterior angle. So I'm going to set up an equation like this. I take x plus 46 equals 134. So I just subtract 48, 6 from both sides, and I get a value of x equals 88 degrees. Okay, now 27. Here I'm going to solve for all the angles. So all the angles means angle H, J, and then G. Okay, so again, I'm taking these two, and I'm adding them together, and I'm setting it equal to the outside. So I set up an equation like this. I take 11x, but 6x minus 1 plus 5x plus 17 equals 126. So what I do here is I want to combine like terms. So I'm going to take 6x and 5x, and that gives me 11. And I'm going to take -1 and 17, and that gives me 16. Then I'm going to subtract 16 from both sides, so I get 110, and I divide by 11, so I get x equals 10. Now I know what x equals, I plug it back into the equations. So I start off with solving for angle H. Angle H is 6x minus 1. So I take my 10, plug it in for x. So I get 6 times 10 minus 1, which gives me an angle H of 59 degrees. Okay, now angle J is 5x plus 17. So again, I take x equals 10, plug it in. 5 times 10 plus 17, or 50 plus 17, which gives me an angle of 67. And then angle HGJ, which this angle right here is this angle right here. So all I do there is I just take 180 minus 126, give me an answer of 54 degrees. So this is this angle right here. And my angle H right here is this angle up here. And then angle J is this angle right here. Okay, now 28 says using the shapes below, determine the following. So lines of symmetry and angles of rotational symmetry. So for lines of symmetry, what I do there is for the first one, I'm looking at how many lines can we use that we kind of cut the shape in half into equal parts. So there's one and there's two. So here I would say lines of symmetry equals 2. And then for my rotation angles of rotational symmetry, I just take 360 and divide it by whatever number this was. So that gives me 180. And then from here, to get my next angle, I just add, it's the same angle again until I get to 360. Okay, so add 180 again. So my two angles here are right here. Okay, now the next one. Okay, so rotation angles, lines of symmetry here. So I have one line here. Okay, one line here. That's 2. And that's 3. And then last one, 4. And then 5. So I have 5 lines of symmetry. So I just take 360 divided by 5. So that gives me 72. So what I do here, I just keep adding 72 until I get to 360. So these are my angles of rotational symmetry. Okay, now number 29, last one. So it says we want to complete these proofs. Okay, so the way we start this is here's to give you this polygon here, and there's two triangles here, and they're asking you to prove that triangle ABC is congruent to triangle CDA, and they give you some information here. So they're telling you that given that AB is congruent to DC, so that's what we start with. That's what's given to us. So over here, the reason they told us it's given, so we write down AB congruent to DC, because that's what's given to us to start with. Okay, now we look at the two triangles here, and you see that they both share this side here. That means that the two triangles share it, which means it's congruent to itself. So we put 2 marks here. So when a segment is congruent to itself, we call that the reflexive property. Okay, so now knowing what we have here, we have enough information to prove them. But if you notice the 90-degree angle here, so I could use this as my hypotenuse leg and hypotenuse leg. Oh. Okay, so that's the hypotenuse leg theorem. So for the reason here, we would say they're congruent by hypotenuse leg. Okay, number 30. Right, 29, the second part. So again here, look at what's given to you. So they tell you that PQ, RS are congruent to each other. So that's what's given to you. So that's what you write down first. Those will tell you that these two angles, PQS and RSQ, are also congruent to each other. So that's another given part. And if you see the two triangles here, they share this side, QS. So you could put 2 marks right here. So we say, remember, when a segment is congruent to itself, reflexive property. Okay, now we look at what's given to us. So this is a side. Here's an angle. And another side. And then look at the bottom triangle. Side, angle, and then they share a side. So the property we use here, SAS, side angle side. So the two triangles are congruent by side angle side. Okay, now the third proof. Right here. So this one we have to fill it out completely. So what we have here is we first of all look at what's given to us. So we say, so try and side LM is congruent to NO. So that's given. It also says angle M congruent to angle O. That's also given. Another thing you notice here on the two, look at the picture here. These two angles right here, it's congruent to itself because they're vertical angles. So you say here, angle MPL and angle OPN, they're congruent to each other because they're vertical angles. So now we want to prove, we have enough information to prove it. So what we have here, this is a side, this is an angle, and this is another angle. So same thing over here, you have a side, you have an angle, and then we have a third angle over here. Okay, so our property here, what we have, in order, angle, side. Oh, forgot to change that. Okay, so cross this part out. And say here, angle. Okay, so it's angle, side. Okay, so now last proof. So here, again, let's look at what's given to us. So we have angle L congruent to angle N. Start off with that. Reason here, it's given. They also give us this part right here. LOM congruent to NMO. Again, that's also given. So again, we want to prove that these two triangles, LMO and NOM, are congruent to each other. So far they give us two angles. But if you notice, the two triangles, they share this side. So I could mark that as these two are congruent. So that means when they share a side, we say MO is congruent to MO because they're a reflexive property. So now that we know that, let's look at what information that is provided for us. So here's an angle. We have an angle. And then we have a side. Like same thing over here. We have angle, and then we have a side. So the property here, so we say the triangles are congruent, LMO congruent to NOM by the angle side congruence property. Okay, so that's all our notes for today.